Monday morning, sprint planning. Someone walks up to the whiteboard, draws three boxes: a producer, a broker, and a consumer. Decoupled architecture, the cleanest thing you will see today. You scale every service on its own, and events flow between them. One team owns the order service, another owns notifications, and the third one owns analytics. Nobody steps on each other. Your retention slide says modern event-driven architecture. Your investors love it. Your engineers love it. The whiteboard also love it. But here's what the whiteboard doesn't tell you. Behind every one of these arrows, there's the 5 lies. Delivery doesn't mean the work is done. Order is not guaranteed. Failures don't surface anywhere visible. Two writes look atomic, but they aren't. And the schema you ship today will not be the schema you ship the next quarter. 5 hidden traps. Every event-driven system has them. The lucky teams find them on a Friday afternoon. The rest find them at 3 a.m. The first lie: delivery does not equal business correctness. Now think about something simpler. A user paid for something, just $200. The event fires, lands at your consumer, the work gets done. Or you think so. Here's the actual story. Account debited $200. The consumer picks it up, updates the database, balance dropped from $1,000 down to $800. Right before it sends the acknowledge back to the broker, the consumer crashes, server dies, pod restarts. Now for the broker's point of view, the work never happened. No ACK came back. So it does what it's designed to do. It retries. A fresh consumer instance pick up the same message, update the database again. Now, balance is dropped to $600. The user just got charged twice for one purchase. Delivery worked. Business is broken. Now Kafka users will say their broker has exactly one semantic. And they are right. But they are right inside Kafka only. The moment you write to Postgres or call an external API, that promise dies. The fix is idempotency. Every event gets a stable ID. Before doing the work, the consumer check a processed message table. ID already there, drop the event. It's not there, do the work. Write the ID in the same transaction. Retries become harmless. The first one debts, the duplicate sees itself, gets rejected, and disappear. Idempotency is not optional. It's the price of admission to event-driven system. If your consumer cannot handle being called twice, it cannot handle production. Lie number 2. The ordering illusion. Now picture a user clicking place order and a second later clicking cancel. 2 event fires into your queue. Same order coming out. But there's a spoiler. SQS make no ordering promises. Kafka does, but only inside the single partition. So order placed, fired first. Half across, it hints a transit error, goes into a retry loop. Order cancelled walks right past it. Order cancelled land first. The consumer says, cancel what? There's no order yet. And it throws an error. A few seconds later, order placed finally arrives. And you have got a ghost order in your system that should already be dead. You cannot ask the broker to fix this. You design for it. Every event gets a version. The consumer tracks the latest version per entity. When an older event walks in after a newer one, you drop it. Ordering is your problem, not the broker. Lie number 3. DLQs and poisons messages. Now let's talk about what happens when things actually go wrong. You have heard of the dead letter queue. Most teams ship one and call it a day. That's where the trouble starts. A DLQ isn't a solution, it's an isolation chamber. And every single message inside of it represents an unprocessed business event. A user who signed up but never got a welcome email. An invoice that was generated but never actually charged the customer. A refund that was issued but never paid off. A push notification that never reached someone's phone. The architecture says the message failed gracefully. The customer says, why didn't this work? Now, the worst case. One bad message, a poison message that nothing can parse. Look at the default SNS retry policy. 3 immediate, 2 at 1 second, 10 exponential. By the time it's done, that single payload has been retried over 100,000 times across 23 days. One malformed event droning every legitimate alert in noise. Good DLQ operations mean 3 things in place from day 1. CloudWatch alarms on queue depth, anything above 0 pages somebody. A runbook that explains what to do when the alarms fire, reply or discard, and a weekly review where someone actually opened the queue and declares it. Without those 3, your DLQ is a graveyard. Failures are not visible by default. You have to make them visible. Lie number 4, the dual write problem. Most producers do 2 things at once. They have to save something into a database and then they publish an event. 2 systems, 2 retries, no transaction across them. That tiny gap is where things break. Watch what happens. The producer saves the order to its database. Database confirms it. Then it calls the broker to publish the order placed event. Between those 2 calls, the producer crashes. Pod gets killed, server reboots, network hiccups. The order exists in the database, the event never went out. Downstream services have no idea anything happened. You may think, fine, I will publish first, then save, but it's the same problem, but in a different direction. Broker accepts the event, database write fails, now your downstream consumer thinks the order exists, and your own database disagrees. Either way, your 2 systems are out of sync. The fix has a name, which is Transactional Outbox. Inside one database transaction, atomic, all or nothing, you write the business row and a row to an Outbox table. Both succeed, or both fail. Then a separate piece of code, a relay, DynamoDB streams, Postgres CDC, event bridge pipes, watches the Outbox table. Pick up the new rows, publish them. The producer never talks to the broker directly. If the relay crashes, it picks up where it left off. Now, event publishing is just another database write. Lie number 5, Sagas and Schemas. The last trap is 2 traps in one. Sagas and Schemas. Both show up after the system been running long enough that everyone's forgotten what they shipped 6 months ago. Most business flows aren't one event, they are a chain. Place the order, charge the card, reserve inventory, ship it. 4 services, 4 events, running in sequence. What happens when step 3 fail? You cannot roll back like a database transaction. You design compensating events, refund payment, release inventory. Each step has to know how to undo itself. And while all that unwinding is happening, the user is staring at a pending state. Eventual consistency isn't a backend problem, it's a UX problem. Now, the second trap. Day 1, your event has a customer ID field. 6 months later, the team owning the producer renames it to user ID. They ship, 2 weeks pass, and all consumer crashes and nobody remembers the rename. The change passed code review, passed integration test. It just didn't pass the contract that lived only inside 3 other services. A schema registry stops this. Every publish gets checked against the contract. Renames, removals, type change, all rejected at publish time, not at 3 a.m. The rule is simple. Add optional fields, never rename, and never remove. Version when you have to break compatibility. Treat every event like a public API, because in a distributed system, that's exactly what it is. Treat every event like a public API. So is event-driven worth all of this? The honest answer, yes. When fan-out is real, when 5 teams need the same event, when workflows are async by nature, EDA wins. But if only one consumer ever reads it, you are not running or building an EDA. You are building an indirect function call with extra latency and worse logs. Before you adopt event-driven, 6 things need to be in place. 1. Idempotent consumers. Every event has a stable ID. 2. A schema registry. Every publish to check against the contract. 3. DLQ monitoring with real alarms, not just a queue, eyes on it. Correlation IDs propagated across every service. The transactional outbox on every producer. And a product team that can show eventual consistency to users without lying about it. If you cannot operate it, you're not ready to adopt it. Operational maturity comes first. The architecture comes second. If this saved you a 3 a.m. page, hit likes and hit subscribe for more architectural deep dives. I will see you in the next video.